Hello, I'm Dawn Swartz, and we were ready to begin a series of strategies for teaching Singapore math. And I'm so glad to have you along with me for these sessions. We want to talk a little bit about how Singapore math fits our classical model of education. We want to give you strategies, lots of strategies. Actually, what are you going to do when you get to the classroom? And what are you going to do when you open up your teacher's manual and get started? We want you to gain confidence in the strategies and thereby gain confidence in your teaching practices. About 8 years ago, our school transitioned from Saxon Math to Singapore Math. And when I think about the success of that transition, it was because our teachers were given the opportunity to train in the strategies of Singapore Math before we ever got started. Our academic dean at the time did a wonderful job of bringing us into understanding the strategies of teaching Singapore Math and what it was all about so that we could confidently begin teaching. And we've learned a lot since then, but it was a wonderful way to get started. That's why I'm glad you're joining me in these sessions, so that if you're brand new to Singapore Math, or you maybe been doing it for a while and you realize you're not really understanding what you're reading about, this is just a way to understand some of those strategies and to begin teaching with more confidence. I'm currently the grammar school dean at our school, Covenant Christian Academy in Harrisburg, Pennsylvania. But I will say the favorite part of my day is teaching math. And currently I teach math in the 5th grade classroom. And I've also taught the 3rd grade curriculum and the 4th grade curriculum. I have observed in all of our classes many, many times. And I've also had the privilege of training in other classical schools, training teachers both in faith-based and in charter schools. And I love watching, as we work together over a couple days of training, I love watching the teachers grow in confidence and get more and more excited about what they are about to do or what they've been trying to do. And there are so many aha moments, or now I see it kind of moments as we work together. So whether you're a brand new teacher to Singapore Math, or as I said, continuing on and maybe have been teaching a little while and really aren't quite sure what you're doing, I hope that this will give you a little background of Singapore Math, which helps in your conversations with parents when they say, well, I don't know, what is Singapore Math? Why do you do it? So a little bit of background will help with those conversations. And then we're going to get right into talking about number sense, which includes math talk and place value and number bonding, and then also do quite a few sessions on model drawing as well. So let's get started together, and let's start with just talking a little bit about why Singapore Math. Understanding a little bit about Singapore Math will help us to see why it fits our classical model of education. And as I just said, it's going to help you in your conversations. It's going to help you talk to parents or talk to the people who they want to know what you do at your school. What math program do you do? And understanding a little bit of background will be helpful to you. So in 1965, Singapore became independent. And you can imagine part of that independence and structuring government and education and all the other aspects of this new country, they were certainly going to do some reforms in education. And so they started, the Ministry of Education started reforms. And in the 1980s, they developed what was called the Primary Mathematics Project. Now, what that project did, or what that group of people did, was to produce instructional materials for teaching and learning primary mathematics, those early primary years of learning mathematics. And they coupled together not only effective teaching strategies, but also the development of their teachers. And I think that is one of the strengths. So great teaching strategies, but it doesn't matter how wonderful they are if your teachers aren't sure how to use them or what to do with them. And that's why you're joining me, because the curriculum is strong and it's proven, but you need to know as a teacher what to do with it. So with that dedication and hard work of both the teachers and the students, that is part of the success of Singapore Math. Also in the 1980s, a team was put together to look at what can we do about the fact that our students struggle at times and have trouble with word problems. And from that, the model method was developed. So in the 1980s, we had the primary mathematics project and also the model method being developed. So that was in the 80s. And by the 90s, just within a decade or so, it was noted that students from Singapore started to score in the top tier of the international TIMSS exam. And TIMSS stands for Trends in International Mathematics and Science Study. That is an international assessment that is given to students in both math and science which would be equivalent to our 4th and 8th grades. So every 4 years to 4th and 8th graders. So in the 90s, students from Singapore started to appear in the top tier of those who scored well. And when the exam was last given in 2015, students from Singapore were at the very top. So that's naturally going to get the attention from international math educators. And for us, it's not about just being at the top of some sort of assessment, but it's about how do you get there and what do you know if you're there? And that is what interests us as classical educators. So what are some of the distinctives and what is a little bit different about Singapore math? If you have taught math for a while, you've taught in other programs, well, before I say that, I do want to say that when we think about strategies for teaching Singapore math, strategies fit whichever one of the Singapore math curriculums you are using. So if you're using the US edition, if you're using Math in Focus, if you're using the Standards edition or the Common Core edition, these strategies are going to remain the same. Some of the differences in those, if you're trying to make a choice, some of the differences are in the scope and sequence. Math in Focus has it really fits what a lot of schools want as for their teachers as far as ancillary materials like tests and notes and reteach materials. It looks a little more like a typical, what we might think of as a typical U.S. curriculum in a school here in the United States. At our school, we use the U.S. edition, and it does look very different in some ways, just in the way the workbooks look and the textbooks look, but we have had such great success with it. So these strategies work for whatever curriculum you're using. So as I was saying, let's look at what makes Singapore math distinctive. What are some of the distinctives? And if you have taught math in the past, you have probably in a year's time tried to get through about 30 different topics on average, maybe some less, maybe a few more. Whereas Singapore math curriculum, if you are brand new, look at the table of contents and there's a book A and a book B, and you'll see that all together you're going to have somewhere between 10, maybe 12, maybe 14 or 15 topics for the year. So fewer topics than a traditional curriculum here in the United States. And those topics are going to be taught to mastery before you move on to the next highest level. Your school will need to define what mastery looks like. Mastery, as Singapore math would define it, is students have the foundations and understand the concepts to where they're actually ready to move to the next level. They have what they need, and you're not going to move to the next level and there will be review, but you're ready to use it. You're ready to, it's a foundation now, and you're ready to use it in the next level and move on. Because you teach to mastery, it's going to be important as a teacher for you to know what has come before you in the grades and the classes before you, and where your students are headed as well, and that will be important for you. Singapore Math also teaches from a model of concrete to pictorial to abstract, and sometimes it's just abbreviated CPA, concrete, pictorial, abstract. You will hear this over and over again in the sessions. As you watch them, you're going to see them in your curriculum, and that just simply means as a new concept is taught, it is first taught with concretely with some sort of manipulatives or objects or something to count or something to use and move around, you will demonstrate as a teacher, but actually for the students to do as well in their own hands, at their own desks, with a partner or individually, so that they can actually understand the number concept concretely. And then it moves to pictorial, and then finally to abstract. And I would imagine in our math instruction, there was some amount of concrete and pictorial, but we zoomed right over that and got to the abstract, which then we had, instead of a conceptual understanding, we had the procedural understanding, and sometimes that made it very difficult for us. So even in long division, it starts out concrete with a place value chart in 3rd grade and place value discs. If you're starting decimals and introducing decimal fractions in 4th grade, you are going to use decimal tiles or something on a place value chart to help them understand the relationship of decimal fractions to the other places, the other place values. So it all begins, if you are the teacher introducing the concept, you're going to do concrete, pictorial, and then abstract. The Singapore math model is also guided by what is called the mathematical framework. It's a mathematical problem-solving framework. And I'd like us to look at this, and this actually comes from the Ministry of Education in Singapore. That you will see this over and over again in Singapore math materials, and it just helps to just have a picture of it and think through it. I will say that I want to work through this just briefly with you. If you are a brand new teacher to Singapore math, it helps to look at it, and then you can tuck it away, because you have a lot to think about as you're planning for your first year of Singapore math instruction. But then you're going to come back to it at another time. You won't pull this out every time you're trying to plan your lessons, but it helps to look at it because you're going to see it and you'll just be familiar with it. If you're a little farther along in your teaching of Singapore math, this might be a good way to evaluate your instruction and think through some of your strengths and some of your weaknesses as an educator. So let's look at it together, and remember that it was developed with the goal in mind so that students could develop their own math and problem-solving abilities. So it's just as an educator, to help think through how will we help our students to have math and problem-solving abilities. So it's a pentagon shape, and we're going to start at the bottom with concepts, and we're going to work counterclockwise around the pentagon. So this is the mathematical framework, and if we start with concepts, this is going to look very familiar to you. These are the concepts of numerical, algebraic, geometrical concepts that we are learning. And as elementary or grammar school teachers, there are a lot of numeric concepts. Everything from fractions to decimals to whole numbers to addition and subtraction are part of the skills, but just all those numeric concepts. There are also statistics, probability, and analysis as well within the concepts. Along with that, in order to develop those concepts, we're going to need some skills. Our students will need some skills. And let me say, before we move on about the concepts, that you're going to need to provide a lot of varied learning experiences to help your students develop an understanding of these concepts. And those are presented to you in your curriculum. And they're presented concrete, pictorial, abstract, lots and lots of activities to lead them through to an understanding of these concepts. Understanding these concepts will help them to apply them and help them to connect them. They're going to need some skills, and you might think of these as procedural skills, and there is a place for procedures in math, but we want them to have a conceptual understanding as well, as so that they can connect. They understand the procedure is connected to conceptual understanding. They're going to need to be proficient in order to learn and apply math with numeric calculations. They're going to need to be proficient in algebra. They're going to need to be able to analyze data, to make measurements. And when I think of this use of mathematical tools, just think if you were a grammar school teacher teaching them how to use a ruler, you have to be proficient at measuring or using a compass or using a protractor. We also, in the classical as classical educators, we talk about those tools. We might even talk about them as being the algorithms. We always talk about the tools we have for problem solving within the classical model. So these two look very familiar to us. I think many of us we memorized and we knew when and how to apply the procedures or the skills, and hopefully had some sort of conceptual understanding as well of what we were doing. But there are three more parts to this guided math framework, three more strengths of the Singapore math program. If we move on to attitudes, and if you think about the beliefs and the interest and the appreciation of math, those things have been shaped by learning experiences or by the way we think or a student thinks about, is math useful? Is it, can I apply it? Or does this have nothing to do with life? It's sometimes these attitudes are influenced by parents who say, well, I couldn't do it either. I never did learn my math facts, and I never did understand math. So those experiences influence a student's attitude, and you know that, and you've experienced that. I've often said I wish there was a little jelly bean that I could give them, a little confidence jelly bean before math, just that gave them the confidence that they can do math, but sometimes they come with attitudes of defeat or discouragement. And then I think about the perseverance. It's the grit needed. It's necessary so that they don't give up when they have a problem that is difficult or challenging, and they need to develop that. And we think about being classical educators and the virtues or the fruit of the spirit and learning to persevere, which I also like it being described as developing that grit to go on and how to tackle the problems. When I think about these beliefs and the attitudes toward math, I'm just always drawn to a story of a student of mine, a previous student I'm going to call him James. And James was going to be in my math class in the coming school year, and the day before school started, there was kindergarten orientation, and he had a kindergarten sister. And so while sister and the parents were at orientation, I saw him sitting in the school lobby. So I thought I'd just go and talk to him, and I was just talking to him about what he was doing for the summer and about his little sister being in kindergarten, just things unrelated to math. But he felt like he better get things straight with me, and at one point in our conversation, he looked at me and he said, I don't like math. He knew I was going to be his math teacher, and he just wanted to lay it out there plain. He said, I don't really like math. Well, of course, that presented a challenge that I kept quietly inside of me, but I just said to him, well, what do you like? And I remember he liked history and he liked literature, and we went on with our conversation, and I never addressed at that moment his attitude about math and the fact he didn't like math, because there are always underlying reasons why we don't like something. But we went on, we started the school year, I started math, and never addressed that, but just working through Singapore math with James and working within that class, I knew at some point the attitudes he had about math started to change, because his mother told me later in the year that she just told me this story, just like James decided he should declare to me out of the blue that he didn't like math. His mom was telling me this story. She thought that I would enjoy, that James and his dad were sitting in a waiting room waiting for a doctor's appointment, and James occupied himself by asking his dad to give him fractions that he could simplify. And Dad gave him one, he simplified it, he wanted another and another and another. And now, you don't usually spend your time in a waiting room doing things you don't like. So somewhere along the way, James was developing in his confidence, maybe even perseverance, to figure out how to reduce fractions or how to simplify fractions. He was beginning to have a conceptual understanding where he was enjoying it. And I think it's important as teachers for us to remember, even when the parents say, I couldn't do that either, and so the children are already have an attitude that they can't do it. Attitudes are not set in stone. They can be changed. And so if you have a student with a discouraged attitude or an I don't like it attitude, as Carol Dweck talks about in her book Mindset, approach them as if there is a growth mindset where they might not like math yet. They might not be able to do it yet. And that attitude it's just not yet. I think that is very helpful. If we move on to the metacognition and the process, we start to move into metacognition, how to think about thinking, how to select and use some sort of problem-solving strategy. Just a wonderful thing we provide for our students by using the Singapore math strategies. Excuse me. And then the process. And this is where we, even as you think about reasoning, communication, and concept, can't you just hear things that we like to think about as classical educators? It's how to analyze math, how to construct logical arguments that are going to help us get to the solution or get to the answer. And then thinking skills and heuristics, another thing that just speaks our language as classical educators. And I just want to, if you're not familiar with that term heuristics, I just want to just very briefly, when you think thinking skills are things that you're familiar with, things like classifying and comparing and sequencing and generalizing and identifying patterns, things you might even do in literature or some other discipline, but you're also going to be doing those in math and teaching them those kinds of thinking skills. Heuristics are we develop heuristics that we use to approach a problem when the solution is not obvious. And our heuristics are experience-based techniques for learning and discovery. And if I could just give you a couple examples, it will make sense. And we do this over and over again in Singapore math. So maybe we teach them to give a representation. We teach them to draw a diagram or make a list or sort things out, give some sort of representation for the material that they do not understand. You can picture, again, doing that in other disciplines of maybe making some sort of diagram in literature for the flow of the plot in a particular story. Another heuristic is in the category of calculated guess, things like guesstimate or look for patterns or guess and check. That is a great heuristic to use in math when you're just not sure what the answer is to the problem, just to look for some patterns and guess or guesstimate. Can also go through a process, maybe act it out. I do this sometimes in class when we're not sure, we're working on a word problem and it's just not coming to us. So I can actually ask students to come to the front of the class and we can act out the story. Or, we start with 8 students, and if 4 of them sit down or go to another group, how did we make half from 8 and take half away? What kinds of things are we doing? So maybe act it out a bit or work backwards. And then finally, just changing the problem altogether. What if we just restate the problem? What if we solve part of the problem? And so in this mathematical framework, all of this is part of what we think about when we're teaching Singapore math. It's not just teaching the concepts or making sure they can work through the procedure. But what about their attitudes? How do they think about thinking? How can they reason through or apply thinking skills or heuristics when the answer to a problem is not obvious? So we want to think about all of those things. And so I'm sure you can already hear, if I say, well, how does this all fit a classical model of education? I'm sure you're hearing it already if you are brand new to Singapore math. It's a very language-based program, and as classical educators, that's important to us. It's constant questions as a teacher, guided and purposeful questions of how and why, and how do you know, and explain your answer, and can you tell me about, or talk to your neighbor about. Can someone explain a different strategy? Constant conversation. And the conversation is not just coming from you as an instructor or the questions, but or maybe the questions are, but then hearing and letting them talk about things, about numbers, and be very comfortable talking about numbers and talking about strategies and learning to explain strategies. So it's very language-based, and we like that. As we just touched on, it keeps problem solving central to mathematical learning. And that's what we desire as classical educators, that we develop students who love learning and look at a problem as a challenge that we can sort our way through and we can work our way through because we have some problem solving skills and strategies. It's not just about learning a procedure, but it's all about learning to problem solve. And then, of course, we love the fact that it teaches all those thinking skills and those heuristics that we just touched on. It just is such a great fit for us. And when I think back as classical educators, when I look back at this mathematical framework, and it's for Singapore math, it is perfect just the way it is. But as a classical educator, I feel like there's one more piece to a framework of teaching math that is missing, and that is that framework does not speak to the beauty and the order of math that is inherent because of our Creator, and that even math points us back to our Creator. It's orderly and it's beautiful, and math is all around us. Math is in creation, and as a classical educator, that's going to come out in your math. Even if it's not in your curriculum, it's going to come out in your math lessons. And as you talk about math, if I could just quickly tell you how this, years ago when I was in the fourth grade classroom and teaching in fourth grade, and I love teaching divisibility rules, which is part of the U.S. edition's fourth grade scope and sequence. And we use the hundreds chart, and one by one we work through the divisibility rules, and it shows up on the hundreds chart in these wonderful patterns. If you're working on the divisibility rule for 3, you go through the lesson and you cross things out and circle others, and you see these wonderful patterns. Well, somehow when we got to the divisibility rule for 5, I can't remember exactly how we got from the divisibility rule for 5 to talking about 5 in creation and God's use of 5 in creation. And somehow we were talking about the apple blossom, and an apple blossom has 5 petals. We went from that to talking about how if you cut an apple crosswise, it has a 5-pointed star. And when I realized that some children had never seen an apple blossom, which is not a surprise, but some of them had not seen that 5-pointed star when you cut an apple crosswise, and I decided we should see that. That would be just it. It's something that they should all see. So from that, we got to where they all brought an apple on a designated day to class, and I went around the classroom one at a time. We put desks in a circle. I cut through the apples, and we looked at the 5-pointed stars. And then what do we have? We have many, many apples cut in half. So I planned in advance that after we cut them, and we just marveled again at the 5-pointed star, and even on a red delicious apple, there's probably an official name for it, which I don't know, but on the bottom of a red delicious apple, you can usually see it almost has like 5 little legs at the bottom that again, that multiple of 5 with the blossom and then the star and then the bottom of the apple. So we have all these apples cut in half, and I planned in advance. They all had paper plates and plastic knives, and they peeled those apples, which had been washed, as had their hands in advance, and they peeled and chopped those apples and put in a crock pot that I had brought to class. And the apples cooked all day, and we had, by the end of the day, the room smelled great, and they had fresh homemade applesauce that they had cut and made themselves. We added cinnamon, we added graham crackers to the event, and that was the afternoon when it became a tradition that I would put on the Redwall DVD, and they would watch the first episode of the story of Redwall. So how did that all happen? Because we were talking about math, and you cannot talk about math without it pointing back to our Creator and just the mind of God, just pointing us back and back again to Him. So those things will happen in your math class. And I love the way Scott Buchanan describes it in his poem, which he says, the structures with which mathematics deals are more like lace, the leaves of trees, and the play of light and shadow on a human face, than they are like buildings and machines, the least of their representatives. So when you start to look at math, it is this beautiful interwoven play of numbers, and it will be delightful for you to work together with your students through that. Finally, as classical educators, we want to develop lifelong learners who love learning just for the sake of learning. That's a goal of each one of us. Remember the story I told you about James, who declared to me he did not like math, wanted to make sure I knew he didn't like math. He never had to tell me that he actually did enjoy math. I knew from his actions, and you will know from the actions of your students that they truly enjoy learning, and they just develop the skills and the understanding and the number sense and the competence through the Singapore math curriculum that you will work together with them. So I'm glad you're joining me. I'm glad you want to think about how will you teach Singapore math and what strategies will you use. And I know as a teacher, you're happy to hear a bit about the history and what it's all about, but you want to know, what do I do? The students are coming in September, at the end of August, and what am I going to do? And that's what this series is hopefully going to help you to. What are you going to do, and why are you going to do it? So when I think about teaching Singapore math, there are two, these sessions are divided into two main areas, and that is the understanding of number sense and how you teach number sense and what is number sense, and then also the model drawing. And I would encourage you just to get an overview of these two pieces, number sense and model drawing, by watching the sessions in order as you have time. The foundations of working with numbers is taught by all levels of math instruction. So I'll begin with number sense, talking about what it looks like in kindergarten, but it builds year by year by year, and so it applies to each and every one of you. We'll talk in number sense about talking about numbers. We'll talk about place value and number bonds, and we talk about those things individually in our sessions, but you will see how they all go together. It's easier to talk about them one at a time, and then you'll see the overlap and how they integrate. Your students are going to have to understand place value. They're going to have to understand number bonds for them to be proficient in math. So then it comes to the model drawing. Even if you're a kindergarten through second grade teacher, you will not be teaching the model drawing, but I would encourage you to view those sessions, as many as possible, so that again you see how what you're teaching builds into that model drawing part of the curriculum. When I visit schools and do training with teachers, I show up usually on the first day, carrying for each of them some sort of binder. And I would encourage you to put together a binder. While I'm there, they act as the students, and I model for them the actual strategies and the actual questioning techniques. So I'm still going to ask these questions through the sessions. I just will not hear your answer. But one thing that you'll want to do is that you're going to actually need to work along with me. You're going to actually need to work along when we get to number sense and we get to number bonds and place value. You're going to want to work along with me. So hopefully you can find a binder somewhere, and please, I would just encourage you to pre-print the accompanying sheets that go along, the problems, the word problems, so that you can work right along with me and make your own 3-ring binder that maybe you will not only keep these things in, but other things, a place to collect other strategies and other really helpful things that will be helpful to you in your instruction. So I think we're ready. I think we're ready to start to explore how students develop number sense. And let's begin in the next session with first talking about how students first learn number sense through talking about numbers. And let's do that together.